Hi guys, welcome back to our channel. If you have never been there, then you should. Its weight has surpassed 8,500 kilograms. Consider an 8,500 kilograms item suspended from the ceiling. Is that even possible? What's the secret? Despite the fact that the chandelier is supposedly suspended by a string, how powerful is the rope in this regard? Because of the existence of the tension force that will be further explained by us, all of these questions will be answered. The tension force is also explained in Newton's third law. When two bodies contact, the two forces they exert are always equal in size and opposing in direction. To put it another way, take a look at this small cable crane Lego. Over here, you can see the object hanging from a cable with the free end attached to the rope. If the cable is severed, the object will fall owing to the gravitational attraction. The object is tied up to the cable is constantly pushed down by gravity, yet it does not fall since it is sustained by the cable. Thus, there exists a force which supports the object against the gravity by pulling it upward. It is called tension. Next, I will pass to Umi to further explain about this tension force.
Thank you, Alia. Now let me explain about the formula of the tension force. The tension on a body is equal to the mass of objects multiplied by the gravitational acceleration, or T equal to mg. T stands for tension in Newton or kg meter per second squared, m for the mass of the hanging item in kg, and g for the gravitational force, which is 9.8 meter per second squared. This formula is used for suspended objects which are in equilibrium state. We can verify that the tension in the rope equals to the supported mass by applying Newton's second law, which states that when a net force is applied to an object, it moves with momentum. For instance, if a 5 kg mass in the figure remains stationary, the acceleration is 0, hence F net equal to T minus W equals to 0, where T and W are the magnitudes of the tension and weight, respectively, and their signs indicate their direction, with up being positive and down being negative. A flexible connection such as a string, rope, chain, wire or cable can only exert pulls in the same direction as its length. Thus, the force transferred by a flexible connector is tension in the same direction as the connector. It's crucial to remember that the tension is a force that acts on the connector. The two ends of the ropes are pulled outward by the tension force. Subsequently, the gravitational force works in the opposite direction as the tension force. If your object is suspended, tension must be used to keep it balanced, or otherwise gravity will pull it down. So to know more about how this concept applied for hanging chandelier, I will pass the presentation to
Thanks Umi for the awesome explanation. Now I will speak more about how a chandelier hangs from the ceiling and what happens if the chain is cut. Will it fall down or float, and most importantly, why? When we apply this notion to the chandelier, we can see that there are only two forces acting on it. The first one is weight, which is the chandelier's mass multiplied by gravity's acceleration of 9.8 meter per second square. And the second one is tension. Weight is directed downwards toward the center of the earth as always, meanwhile the tension force is directed upwards. Because the system has no acceleration, the net force is also zero according to the F equal to ma or F equal to net force equation associated with the Newton's second law. In order for the net force to be zero, the magnitude of mg and t must be equal. Because mg and t generate a force pair, these two forces are equal in magnitude but opposite in direction. This finding is also related to Newton's third law. So, the chandelier hangs from the ceiling rather than crashing to the ground because of these forces of equal magnitude and opposing direction. Next, what happens if the chain of the chandelier is cut? The chandelier will not be in equilibrium state, or the opposing forces will be uneven when the chain is cut. This causes the gravitational force to be larger than the tension force. The chandelier descends to the ground and accelerates downwards due to gravity, while the chain becomes slack and loses the tension force that holds the chandelier in place. That's all from me, Alia and Umi about the tension force. I hope you guys enjoy it and see you guys next time.